Kira Blackwell from NASA headquarters, and on behalf of our NASA iTech team, I would like to thank you for joining us for Ignite the Night Houston. Tonight we're going to be live streaming, and yes, that's kind of new to me too. But can I ask everybody to sort of give it a shout out to the live streamers that we have? So Jess got a camera over there and she's panning the audience. Everybody just kind of go shout out. Woo! Thanks for joining us. Thank you. Anyway, I just think we need to sort of come up to stage with what new technology is doing, and it's a stretch for me with live streaming, but we appreciate you guys joining us today. Let's get this evening started. Since we continue to have different audiences, I'd like to explain exactly what NASA iTech is. So let me kind of go through that. As you may already know, technology is moving at a very exponential rate, and we have to sort of either jump on the train or we'll miss it. And what I know is NASA doesn't have all of the answers, and neither does anyone else. So in order for us to accomplish our mission, I think we need to work together with various organizations, universities, entrepreneurs, to probably be able to accomplish that mission as quickly as technology is advancing. The NASA iTech program conducts 2 solicitations a year, and we hold 2 big forums. Tonight's event, Ignite the Night, is a mini version of whatever our forum is. And so we're sort of reaching out across cities throughout the US to identify technologies that can meet our needs, that will build an ecosystem of entrepreneurs developing cutting-edge technologies in various areas that will have both an Earth application and a space application. So that's why we're here tonight. We're here to hear technologies about autonomous robotic capabilities, medical breakthroughs, and we also have an XFactor category that we're usually searching for technologies for. So the Ignite the Night is to highlight those technologies as the entrepreneurs are giving a 3-minute pitch this evening. Those technologies will be judged or scored by a panel of judges that is a mixture of NASA subject matter experts, chief technologists, or principal technologists, as well as industry leaders or serial entrepreneurs. We do this for 3 reasons, because we know that the technologies are moving fast, NASA has a limited budget, and we could use your help, entrepreneurs out there developing the technologies. Often you're developing things that you might not know has a space application. So we're focusing on artificial intelligence and autonomous robotic capabilities, and these are some of the needs that NASA has. So I thought it might be important to kind of share those. Extraction of materials and hauling, autonomous construction and assembly, robots that can operate from fault recovery autonomously due to distances from Earth, robots that can make decisions like a scientist even when they're unknown in an unknown world. Those are all important capabilities, and those technologies are being developed in other areas, in other industries. And if we can somehow leverage that and work together with those other industries, it would be really beneficial. Medical breakthroughs is another area that we're looking for, from approaches that lab analysis technologies, flexible ultrasound technologies, in situ production capabilities for medical or food. I mean, if we can figure out how to extend the life of food or medicine for long duration flight, that would be really beneficial for us. And technologies that can actually help us with surgical procedures that are happening in space, right? Where you can't train an astronaut to be at a certain caliber of a doctor. It would be great if we had surgical pods. And we always have an XFactor category, because when I started this program, I really thought, well, we're going to give the focus areas, we're going to leave them broad, and entrepreneurs are going to be able to fit their technologies in those focus areas. And it didn't exactly work that way, because the feedback I received from the entrepreneurs, which we've changed since then, was that really there were things that they're developing that we hadn't thought of yet. Technologies that they're developing that could be applied to something that we hadn't considered as a solution. And so we created an XFactor category so that if it's something that you're developing that we hadn't thought of yet, and you're thinking, wow, NASA needs to know that we're developing this, that would be great. Many technologies that NASA does develop are very specific to addressing our mission and our mission's needs. And there's really never going to be a commercial market for some of those things. However, NASA ITEC is looking for the things that actually do have a commercial market value and have a commercial market so that the technology can move forward, but also can be customized to work within the space agency. If we can buy a computer and modify it and use it in a zero gravity environment, we've saved taxpayer dollars, we've actually done it quicker, and we all benefit from that. And so that's why we're here. So you might be wondering how well this has worked in the past. So in the first 6 months, our cycles run about every 6 months. We received about 200 proposals, 30 entrepreneurs presented, and those entrepreneurs have been able to leverage $210 million in a very short time period. That's private investment dollars. That's not NASA funding, that's not NASA grants, it's not federal dollars, it's not your taxpayer dollars. That's actual investment dollars that are investing money in those technologies that can have a dual use. And that's substantial. There's no accelerator in our country that has those numbers. And we're not even a brick and mortar organization that is actually working with them on a regular basis. We just help them a little bit. We have some of our chief technologists that evaluate the technologies and help move it forward. But that number right there speaks volumes about how this model works. So we've decided to bring this to your city, Houston. Anybody want to shout out from Houston? Isn't this H-Town? Anything significant happen a year ago? Harvey? So entrepreneurs need courage to do what they do. They need to have quite a bit of endurance to be able to withstand the pressures of being an entrepreneur. And they really need an ecosystem in their surroundings to help them move that technology forward. And of course, they always need funding. But those are the things you have here in Houston. And autonomous robotic capabilities, you have those here in Houston. And medical breakthroughs, last time I checked, there's people that will travel from other countries to actually come to Houston to the medical center to receive treatment. You guys have the environment, the community. Look around you. You guys have the community to be successful as an entrepreneur. And at the end of the day, we're doing this, one, to build a platform, but two, because we need those same technologies that you guys are developing. And so I hope that you will, at the end of this evening, you'll find that your time was of value being here as an investor, as an entrepreneur, as an industry leader, to be able to see what's being developed, work with it, and possibly discover a technology maybe you would invest in, or you would spend time with, partner with. So who's ready to see some technologies tonight? You guys got to give me a little more than that. Who's ready to see some technologies tonight? Thank you. I am pretty excited because, well, I've had a preview. I've read through the proposals, so I know what we're about to see. They're amazing technologies. But before I introduce them, I want to go through a little logistics. In a few minutes, we're going to hear from 11 presenters. They're going to give you their best space elevator pitch. Each pitch is 3 minutes. And they're going to tell you a little bit about their technology and how it can potentially solve a problem for NASA. And in true NASA iTech fashion, where we lean on both our internal experts and external experts, we have panels of judges here that have volunteered their time tonight to evaluate the presenters and their technologies. And what they'll do is, as the presenters present, at the end of that, they'll have about 15 minutes to do Q&A. And when they do that, they're going to go and convene Come back, we'll select one winner, and that one winner will move on to being one of the top 25 for our forum that will happen in October in Hartford, Connecticut. So I'm going to have the judges introduce themselves.
Ronnie Clayton, the Deputy Chief Technologist at the Johnson Space Center.
I'm Bob Prochnow, Executive Director of the Technology Collaboration Center.
Scott Schneider, CEO of HTX Labs.
I'm Joseph Trahan with Energy Petroleum Services.
Terry Taddeo, Chief Medical Officer at Johnson Space Center.
And Chris Colbert, Chief Technology Officer at Johnson Space Center.
Vernon McDonald, Senior Vice President, KBL Wiley.
Joy Kelly with Jacobs. Kim Hambicken with NASA Johnson Space Center.
Fred Harrier, Chief Technologies at Jet Propulsion Lab.
I'm Rob Ambrose. I'm the Chief of the Software Robotics and Simulation Division at NASA's Johnson Space Center.
Can you help me thank these judges by a round of applause for giving their time tonight? They gave up their Monday night to be here. I don't know, there might be some football fans in here, but they gave it up just to be here for you guys. So thank them. And I also want to thank my team for actually doing this, because without them, we'd be standing on a corner somewhere in some city, because I couldn't do all of this by myself. They're amazing, and I couldn't do it without them. And so if one more round of applause for my team. They're amazing. So it's time to get started. So please help me welcome the first presenter up on stage, and then we'll hear what their technologies are. Thank you.
By a show of hands, how many people here love the smell of stinky workout clothes? There's always one. Well, most of you don't, so you're going to love my presentation. And imagine stinky workout clothes on astronauts working out 2 to 2.5 hours a day in outer space. How gross that must smell. Oh, and by the way, they don't have washing machines. My name is Megan Eddings. I'm the founder and CEO of Excel Lifestyle. With my chemistry background, specialization in biochemistry, and experience in science labs at Brown University and UVA, I have custom created a solution to this stinky clothes problem. Basically, the workout industry is estimated to be $350 billion by 2020, and Excel Lifestyle, we want to revolutionize that market. Excel Lifestyle is the first ethical fitness apparel brand for people and astronauts who sweat and want to smell fresh, and we have a fantastic team. We have PhD scientists, we have patent attorneys, and my favorite, the yarn geeks. So basically, with my chemistry background and my team, I can proudly say that the fabric is now patent pending in 120 countries. And basically, it is antimicrobial fabric. So what happens today is the bacteria that we all have, they get lodged in your clothes, specifically when you're working out or really when you're doing anything and you're sweating. And you can't wash that bacteria out. So whether you're working out on Earth or you're working out in space, that bacteria literally lives in your garments, and they continuously wear those same clothings. And honestly, I'm going to say it again, it's gross. So what we do is I've combined natural fibers that decompose, synthetic fibers, and trade secret protected science that's embedded in the fabric. This helps, obviously, fitness enthusiasts to smell and stay fresher longer, but also astronauts. We have over $40,000 in pre-sales right now, and we are finalizing the ethical supply chain. What this means is, it's really important to me and my team that everything is sourced and made here in the United States, and that there are no sweatshops used. And I personally visited every factory, cut and sew mill, etc. And really how this happened was about 3 years ago, my husband and I are super into fitness, and I was just tired of throwing away his workout clothes because they stunk. So I looked to the market to see what was out there, and there are other options out there, but there wasn't something to the elevated experience, so I decided to create it myself. And so here we are on Earth. We have gravitation, and the gravitation obviously pulls on your muscles and your bones, etc. Right now, you guys are kind of all working out, even though you're just sitting here. And in space, they actually have to work out 2 to 2.5 hours every single day to make sure that they don't lose muscle and bone. So they would love, obviously, the Excel Lifestyle fabric, not only for themselves, the astronauts, to feel and smell fresher longer and not be carrying that bacteria in their fabric, but everyone around them will love them as well. So we're starting out with shirts. Once again, my name is Megan Eddings with Excel Lifestyle, and we have technology in our textiles, and we focus on comfort and function.
Hello everyone, my name is Thomas and I'm the CTO of Airway Medical Innovations. We're currently in the Texas Medical Center Accelerator Program. Our founder and CEO, Dr. Julio Alonso, is an ICU clinician with 20 years experience in the field. And he thought we can improve endotracheal intubation. Endotracheal intubation, for those of you who don't know, is the placement of a plastic tube into the trachea to facilitate mechanical breathing during emergency and surgical procedures. This procedure is carried out with your two hands. On spaceships, they use LMAs, or laryngeal mask airways, which are a temporary solution to a potentially life-threatening problem. To put this into perspective, LMAs are also used in the back of ambulances, so while the patient's being rushed to hospitals, the crew can temporarily secure the airway. Now, once they get to the hospital, the LMA is taken out and the ICU clinician, like our founder, will put in an endotracheal tube to properly secure the airway. Now, this might be fine if you're 5 minutes away from a hospital, but if you're on your way to Mars. The goal of Airway Medical Innovation is to bring safe intubation everywhere, and our solution is a shuttle scope. A one-handed, one-step integrated solution where the endotracheal tube is held on the inside of the laryngoscope and is always ready to be deployed with a simple movement of the thumb. Now, why is this better than conventional laryngoscopes? Firstly, it completely gives the operator complete control of the placement of the endotracheal tube and completely frees up their other hand to perform other maneuvers, such as use of manipulators, suction of extravenous fluids, or applied crochet pressure. So we currently have fully functional prototypes developed and are moving on to clinical trials and manufacturing. The goal of Airway Medical Innovations is to become the gold standard in intubation, and we are bringing safe intubation literally everywhere. Thank you.
Human beings are explorers. We've long dreamed of living beyond Earth, but we can't do that alone. We need robotics to help get us there. The problem that we have today is that we don't have robots that are capable enough of helping us to create settlements on other planets, until today. At Optronic, we're bringing forth the next generation of robots that will help to expand human life beyond Earth. Hi, my name is Jeff Cardenas, and I'm one of the co-founders and director of innovation at Optronic. We're a spin-out from the Human-Centered Robotics Lab at the University of Texas at Austin, and I'm joined here tonight by Dr. Luis Sintis and Dr. Nick Payne, who had the great fortune of working on NASA's Valkyrie humanoid project. We still have students from the lab that are working on Valkyrie today, and we've learned a lot from this amazing machine. We've used all the lessons that we've learned to create a next-generation humanoid platform that will change the way we live here on Earth and will take NASA and space exploration into the future. So we were founded in 2016, and we've been hard at work ever since. We've innovated in nearly every aspect that makes up a robot. So all a robot is actuators, which are the muscles of a robot, control systems, which is like the nervous system that controls those muscles, sensors, and software, which is like the glue that ties everything together. And at Optronic, we focus on the building blocks for any type of advanced robot. So that will allow us to fulfill the needs of anything that NASA might come up across in the future. On the actuator front, we've made some major breakthroughs. We've pioneered liquid-cooled viscoelastic actuators, and we have some new breakthrough actuation technology that's truly a game changer. These actuators make robots more lightweight and powerful, yet efficient, robust, and dexterous than anything before, yet still safe for human beings to be around. We have some major actuations on the control front, and we also have opened up our software platform and completely overhauled it to make it easy to implement next-generation AIs. And we're just getting started. The goal here is to create a humanoid platform that can meet or exceed human-level performance, and this has major implications both on Earth and in space. These robots will do the 3Ds, the dull, the dirty, and the dangerous. So in space, we'll send robots to do things that are too dangerous for humans. For example, on the moon or on Mars, we can send robots ahead of us to colonize settlements and get them ready for human beings to come there. On Earth, the market for this is enormous. Some analysts predict it to be the next trillion-dollar industry in advanced robotics. We'll use these robots for everything from construction to logistics to firefighting to disaster relief to nuclear waste cleanup. The list goes on and on. Right now, the humanoid that you see here is the lower body that we're developing for the Office of Naval Research to be used for firefighting and logistics on board naval ships. We're really excited about what we're doing. We did about $1.5 million in revenue last year. We're expected to do over $3 million this year, and it's an absolute honor to be here and present to you guys today. Thank you very much.
Good evening. My name is Josh Rabinowitz. I'm co-founder and CEO of Articulate Labs. I've emerged from the TARDIS to tell you about our work in wearable medical devices that help turn everyday activity into on-the-go physical therapy and rehabilitation. In the US, the earthbound issue is that over 100 million are estimated to have some form of musculoskeletal condition that would require physical therapy. Less than 10%, though, actually go to physical therapy. Those who do either get it prescribed or have a regimen we discovered that nearly 70% of that population is either not able to make it to all of their sessions or non-compliant with their at-home regimen. There's a big gap right now that exists in the need for physical therapy and how it's administered with its population. And we believe we've got a platform technology to help fill that gap. What we've done is taken neuromuscular electrical stimulation, a technology that's been proven in the physical therapy clinics to assist with muscle strengthening and activation, and improved it by integrating motion tracking hardware and machine learning in order to align stimulation with movement and with expected muscle activation. The first application of this technology that we're pursuing is strengthening quadriceps muscles for those who are either dealing with chronic knee conditions, we're at 14 million in the US, or another million who are recovering from some form of knee surgery, altogether forming approximately a $5 billion knee treatment market. To date, we have working prototypes that we have tested and validated over the University of Texas at Austin. Aside from seeing a high degree of accuracy in both stimulation timing and location with those with a wide variety of gait irregularities, we've also seen positive changes in muscle activation and joint range of motion in a short time of operation. The spacebound problem we're looking at, as mentioned by Excel earlier, is that in weightlessness, within 2 weeks, astronauts can have a loss of 20% of muscle strength, and that they would require 2 to 2.5 hours of physical training every day in order to maintain their strength. Our thought with our technology, combined with astronaut effort, is to be able to optimize their physical, to optimize their straining, their work on the either on the space station or on a longer trip out somewhere like Mars, as a way to help them maintain strength and do so in a way that's optimized, helping them restore time to critical mission focuses. We are currently, though, focused on our knee rehabilitation product, looking at launching that in early 2019, currently working on optimizing the design and getting further improvements out of our team with extensive experience in control systems and embedded design background. Look forward to having your questions. Thank you very much.
Elon Musk wants to send you to Mars, but SpaceX is not working on food or life support for the journey or the colonies. NASA is, and we are. To take this 1 pound of food to space will cost $10,000. To the moon, it will be double the price. And to Mars, it will be 100 grand. That's the cost of a Maserati. A crew of 4 on a 3-year Martian mission would require 24,000 pounds of food. So taking the food with us comes with an astronomical cost. It's also very risky because if anything goes wrong with the food, everyone there would starve to death. That's because resupply is not an option. My name is Moji. I'm a co-founder at Samhita Factory. We're a team of scientists, astronauts, and entrepreneurs, and we have a solution for this problem. We plan to use the 1 kilogram per day of carbon dioxide that astronauts breathe out. And on Mars, we plan to use the 96% of the carbon dioxide in the Martian air and convert it to food, nutrients, and pharmaceutics, starting with glucose. Basically, we're building a bioreactor that takes in carbon dioxide, sunlight, and water and converts it to glucose. Does that sound familiar? That's exactly what plants do via photosynthesis. This technology will enable NASA to create a regenerative life support system that doesn't exist today. But our customers would also include NASA contractors, private space companies, and space tourism. On the terrestrial market, we're speaking with Department of Defense, and they're interested in this technology as a way to biomanufacture nutrients and pharmaceutics in remote locations, field hospitals, and also for disaster recovery. A wearable version of this technology would also disrupt the established and commercial diabetes device market that's worth $30 billion. So we're solving real-world problems in space and on Earth. We started the company a year and a half ago right here at a station Houston, and we're also part of the Capital Factory Accelerator program. Since then, we have won the MBR Space Settlement Challenge, and my brilliant co-founder Tara there has also published the book with Brinker explaining the science behind the technology that we're deploying. So when you think about it, Mars landing is the biggest achievement of humanity in our lifetime. And we want to be part of that and looking forward to other passionate people who would like to discuss that. Thank you.
Operating a satellite is exhausting work where every single decision has to be micromanaged and is often time constrained. What if a satellite could decide on its own how best to achieve its mission that we give it? My name is Guido Carufel, CEO of Cognitive Space, a Houston company developing autonomous systems for the satellite industry. Over the past 11 years, I've developed award-winning flight software for NASA, autopilot systems for launch vehicles, and high-fidelity simulation models to train our astronauts. Today, the satellite industry is valued at $270 billion, with about 2,000 active satellites in orbit. In the next 10 years, that number is expected to grow to 8,000, with a total market of over $1 trillion. Yet there is already a global shortage of aerospace engineers, which stresses the importance of automation in this industry. Satellite operation is both tedious and repetitive work, which requires experience and a high level of understanding of onboard systems. Modern AI technology is precisely well suited to address this type of work. Companies in virtually every industry are investing heavily in AI technology to automate repetitive tasks to increase efficiency, while virtually every satellite manufacturing companies still rely on very traditional custom software. Considering that we are entering a new phase in the satellite industry where spacecraft components are increasingly being commoditized, it is the right time to challenge the current paradigm of satellite operations with a new superior commercial satellite software product. Just as Microsoft Windows radically transformed how we develop applications and interact with our personal computers, we are working to radically change how satellite software is both developed and operated. We are building an integrated system with both a space and a ground component. The space component is a data-driven autonomous operating system built as an executive layer over a flight software framework developed by NASA. The ground component is a machine learning training framework integrated with a web-based user interface to enable our customers to set mission priorities for their satellites. Our core technology is based on a lesser-known branch of AI called reinforcement learning, where we teach our systems to make the best decisions based on rewards feedback. Our proof of concept prototype applies this process to train a satellite to select the most appropriate target for observations based on objectives set during training. In short, we want our satellites to autonomously decide what is the best decision based on its current state and the priorities of its end user. Thank you.
"71% of our Earth's surface is covered with water. 2.4% of that is fresh. 0.007% of that is easily accessible to 6.8 billion people, and our population is growing. That's the challenge we want to solve. We want to solve the water challenge. Our team is a Danish aerospace company in North America, myself, and our team, which has 30 years of experience, Danish aerospace company in Denmark, with our sister company, Aquaporin, in Copenhagen, also in Denmark. And we think our technology has the ability to be able to change the paradigm on how we process water. We use a technology that basically is based off of our liver and kidney. It consists of a protein called Aquaporin. And that protein basically isolates water and rejects all the contaminants from the system so that you're only getting clean water for vital functions like thermal control in your body and nutrient delivery, and a host of other things that help cognitive functions, things like that. And the trick really has been trying to integrate this protein into an engineered material. So we have a hydrophobic membrane that also ionically attaches to the aquaporin protein that allows selective passage of water while rejecting all the contaminants. And the trick really has been to making it an engineering system so that you can have recoverable water at a decent flow rate. So the key to this is really, again, just integrating the protein in the engineering material, but the nice thing about it is that we've had thousands of years of evolution behind it. It's based off the human body, which rejects water already. It lasts for 79 years, so reliability is extremely high. It's passive, there's no power, there's no moving parts to it. So on the ground, we think our addressable market is for disaster relief and recovery. So we're developing prototypes for disaster relief and recovery for things like Hurricane Irma, who hit Puerto Rico. We had 121 cases of and four confirmed deaths of lip cirrhosis, a rare bacterial infection that is passed through urine. So our system can process wastewater just like it does in the body and urine so that you get clean, deliverable water to a community on the ground. We think this has a lot of applications to space as well. It's low power, it's no moving parts, and it lasts for 79 years. It's our body. So in deep space exploration, we think this is also one of the biggest challenges that you have to face as a space community. We really hope to enable interplanetary space exploration through our low power system, which we currently have, and it's operating on the ground. We have about $43 million in assets and venture put into the system already. So we think we can pull it off on the ground, but really would like to do it for spaceflight. We look forward to helping you enable interplanetary spaceflight. Thank you.
Good evening, everyone. Please take a look at the person to your right. Now take a look at the person to your left. Statistically speaking, one of the three of you already has at least one form of cardiovascular disease. If you're over 60, that chance doubles. Again, that is statistically speaking, and I hope this room is an exception, but the fact of the matter is that over a third of all deaths globally are stress and cardiovascular disease related. Heart attacks and strokes cost America nearly $1 billion per day. And this is just one of the issues that my company is addressing. I'm Irene Brinker, CEO and co-founder of Diwali, a 100% female-founded company headquartered in Austin, Texas, with our R&D team, lovingly nicknamed the IP Factory, over 20 scientists and engineers with resumes ranging from the Mayo Clinic to Microsoft in Ukraine. And we are on a mission to save lives. While we are a new company, we are not a new team. Having previously won 2 Consumer Electronics Show awards for the world's first fully autonomous EKG and heart rate variability monitor for one hand, we've chosen to act on the previous years of feedback and move away from the wrist. Partnered with Thorlo, the only socks clinically proven to improve foot health, to create a comprehensive yet comfortable and unobtrusive remote monitoring solution in your socks. Umen, meaning smart in Bulgarian, combines our proprietary sensors into one comfortable sock-based device with multiple user interfaces to track, monitor, and study biometric and physiological performance data, ranging from stamina, exhaustion, stress, emotional state, sleep patterns, to pain levels, core body temperature, hydration, blood oxygen saturation, and heart rhythm abnormalities such as AFib and arrhythmia. Customizable multifunction dashboards allow for simultaneous remote monitoring from multiple access points. In space, this will allow astronauts to better understand their and their teammates' physiological responses to external and internal stressors, and mission control and medical staff to better care for them at a distance. Logging long-term data allows for deeper analysis, and the truth is that we're all still learning exactly how space travel affects the human system. This type of constant monitoring solution will allow for in-depth analysis on subtle changes to homeostasis, and not just the problems themselves, but how did we get there? On Earth, we believe this will be the next revolution of remote patient monitoring, promoting early diagnosis of infections and heart conditions and reducing hospital readmissions. I'm Irene Brinker, CEO and co-founder of Diwali, and we're on a mission to save lives. Who of you wants to join us?
In intensive care units, sometimes you can spend several minutes and even hours alone, feeling pain, sometimes having spasms or delirium, and no one will notice because in that certain time you are alone there. It happens. I'm Paulo Pinheiro, CEO and co-founder of Holobox Robotics, a startup that uses artificial intelligence and robotics for improving the human well-being. We are a team expert in machine learning, and we are here in J Labs at Texas Medical Center. And we have 5 PhD experts in machine learning, robotics, and also human behavior analysis. What we are developing here is the most precise facial recognition software capable of detecting facial expressions and then with a high precise detect some human behaviors. It's more precise than any other technologies have available today, because we develop specialized for healthcare applications. We have 2 applications right now, 2 different markets. The first one, we embed this technology inside wheelchairs. So we are helping quadriplegics and people diagnosed with ALS to control a wheelchair using facial expressions, just using a camera mounted on the wheelchair. Then we took this technology from the wheelchair and put inside intensive care unit beds to solve the problem I mentioned before, to detect 10 levels of pain, spasms, delirium, and other human behaviors. Well, we know that in this space, part of the crew spend part of their time doing video conference calls. And also you have 2 bots in the space right now. The first one, it's a kind of companion robot. And the other one, it's a kind of documentary bot. It's taking pictures and making videos over there. We have embedded our technology in many devices. We have clients in Brazil and here in the United States in different segments like retail, security, transportation. So we know how to embed this precise technology inside those robots, inside those computers. And we believe that we can make those bots smarter and more valuable for their missions. Will be just like having someone take care of you all the time in this space. Thank you.
If you hire an electrician to replace a light bulb, you expect them to walk through the door, not punch holes through the walls in a path to your living room. However, surgery today requires cutting just such a path, even though there exist suitable pathways that lead to almost every inch of your body. These pathways include blood ventricles, the spinal canal and brain ventricles, and the urinary tract. My name is Aaron Becker, and this is Dr. Julian Leclerc. As a professor at the University of Houston, our team has developed a suite of patent-pending miniature robots that fit inside the pathways of the body. These robots are simple and can be 3D printed and outfitted with specialized tips for a variety of surgical interventions, drug delivery, and biopsy. We can make these robots simple because they are steered and propelled by electromagnets placed outside the body.
In clinical MRIs, the same set of electromagnets we use to image the pathways of a body can be used to control our miniature robots. We have developed several key technologies that greatly increase the forces our robot can exert. Our team includes MRI sequence programmers and the director of the MRI laboratory at Houston Methodist Hospital. The surgical robot market was $3.5 billion in 2017, mostly driven by minimally invasive surgery. Our technique to enable non-invasive surgery causes even less damages, reducing infection risks, reducing side effects, and reducing the recovery time. We're in year 2 of our $0.8 million NSF grant, de-risking this technology using MRI scanners. We will finish miniaturization and phantom test Q2 2019 and then begin animal trials.
Our initial focus is precision drug delivery and cyst fenestration. A cyst is a blister, so cyst fenestration is a fancy word for popping a blister inside the body. This tech addresses a current need for NASA that will only increase as space missions become longer. If you're a science fiction fan, you know that when blood is spilled in space, it goes everywhere. Poking holes in astronauts contaminates their living environments with blood and bodily fluids. Rather than open up our patient, our systems enable remote control of tiny robots that are inserted via needle and then swim through the body passages. This remote actuation highlights another benefit. Our technologies are suitable for partial or for full automation. Now, MRIs are heavy, so for space application, we can get the same localization with lightweight ultrasonic scanners and power the robots using copper coils. So in 2025, when an astronaut is suffering with a cyst inside the skull, we can swim our robots there. Thank you.
Chemical reactions form the basis of human civilization. They make fertilizer for food, fuels for transport, plastics, and other raw materials. Just as these reactions are the basis for human society on Earth, they will also be the basis for society in space. My name is Trevor Best, and I am the CEO of Syzygy Plasmonics. We are developing a new type of chemical reactor that operates on recent advancements in science. At the core of our reactor is the world's most active and efficient photocatalyst that we have licensed from Rice University. This catalyst enables us to build a reactor that is powered by light, not heat from burning fuel. Because we do not need heat, we do not have to burn fuel. Because we don't burn fuel, we do not produce carbon emissions. We are capable of building a reactor out of low-cost, lightweight materials. We have demonstrated this technology on dozens of different reactions, and what we are seeing is the capability to produce commodity chemicals at a lower cost with no carbon emissions. Let's talk about 3 of those reactions today. The first one, making hydrogen gas. Our go-to-market product will be a small-scale hydrogen production system that will be able to produce hydrogen at a price point that makes it cost competitive with gasoline. So we have already built a small-scale prototype, and it is working so well, it has allowed us to raise venture capital from the West Coast and gotten a number of customers interested in field trials in 2020. But that's great, right? But we're here to talk about space. So what can we do for space? In the middle here, you see the Sabatier reactor. This is on the International Space Station. It takes and processes carbon dioxide to recapture water for the astronauts to use. As you guessed it, we can do this reaction as well. When you build a Sabatier reactor out of our technology, you reduce its weight, making it easier to get into space. It operates at low temperature, making it easier on the spaceship's very delicate temperature management systems, and you also increase its uptime and decrease the maintenance required to keep the system operational. Now, let's talk about the third reaction I wanted to talk about, splitting nitrous oxide. We can take nitrous oxide and split it into 30% oxygen, 70% nitrogen. This is breathable atmosphere. If you couple this with an inflatable module, like the Bigelow Expanding Activity Module you see there that is already deployed on the International Space Station, you get the capability to send dozens of these up into space on a single launch and use our reactor to decompose the nitrous oxide and inflate them and enable a rapid expansion in space infrastructure over the next decade. We are very excited about this new technology. Once again, my name is Trevor Best, CEO of Syzygy Plasmonics. If you'd like to discuss any of this, please come talk to me in the back. I'm the last speaker, so give it up for these fantastic entrepreneurs here today. Thank you so much.
Ask for an applause, but can I ask for a better one? Because these are pretty amazing technologies. One more time. So you guys might be wondering what the sounds of Saturn were. The judges need about 30 seconds to tally their score, and so that's why we do that. But it is NASA ITEC. So I thought I'd give you a little sound that we hear on a regular basis. So we thought we'd share that with you. The judges will be heading off shortly to tally the scores. They've got about 15 minutes before they head off. And before they do that, are you guys good? My mic is, I don't know. You guys good with your scores? Okay. So if you guys can, oh yeah, you guys get to ask questions. Darn it. I was ready to select a winner. Okay, so the judges are actually, they've got about 15 minutes to ask, or 10 minutes to ask questions. They've got about 10 minutes, and Robin's going to give them their minute back that I just took. They've got about 10 minutes to ask questions so that they can tally their scores. So just keep you guys have a timer on the other side, and you will hear shark music if you guys go over, just like the entrepreneurs did.
Question for Irene.
I'm holding a mic.
Okay. Why socks, and how can people have that many socks with biometric tech in them?
That's a fantastic question. So there's a number of reasons why socks. Our last company, we had something on the wrist, and we found out that consumers, even those with health conditions, are very confused about the difference between EKG and their Apple Watch. So socks made sense because it's fully unobtrusive, right? As far as how many pairs of socks, we're probably going to be making a concept socks where all of the sensors are embedded, but you're absolutely correct. More than likely, in real life, it's going to be a removable device for regular people so that they can change out their socks. We're partnered with Thorlo, the only clinically proven socks to actually make feet healthier. They have a foundation built for it. So we have different types of socks depending on what's actually happening with the person.
I have a question for Josh. Do you have a closed loop control between the position sensor, say of the knee, and the stimulation, where you can move the knee with a closed loop control system?
So what we have at the very beginning, we have we have input from either the overseeing physical therapist or physician in order to calibrate the device to the patient's gait. Trying to operate on a pre-programmed stimulation sequence we found was not accurate enough. So there's going to be a brief calibration process, and then after that it's going to go closed loop, taking that position data from femur and tibia and running that through a real-time operating system that's effectively modeling the knee, using that to drive differential stimulation.
All right, this is for Jeff. So
Yes.
how does the liquid-cooled actuation compared to hydraulic actuation that we're seeing in current robots for terrestrial purposes?
Yeah, so the goal of our actuators is to try to meet the same level of performance that you get out of hydraulic actuators, but solving for efficiency. So basically, they match the same level of performance that you see in these hydraulic actuators, but they're much more efficient, which is really important for mobile robotics. Thank you.
This question is for Josh. Do you have any feel for the power consumption of your system yet?
So what we've seen in the working prototype that we have right now, that's going to last about 6 to 8 hours on just a couple flat lithium polymer batteries, about 1,400 milliamp hours between them. So 6 to 8 hours of operation, 60 to 90 minutes duty cycle worth of stimulation.
Okay. Thank you.
Question for Thomas. Thomas, do you have any data on how long it takes to be trained to use your device and how reliable it is for airway management?
So we haven't started clinical trials yet. We're moving on to them very shortly. So I have to get back to you on that.
Okay, I got a question for Aaron. Can you spend another minute describing how you replace the MRI in a space vehicle?
Sure. I'd love you to come over to our lab, which is right at the University of Houston. And we've got one that is large enough, a magnetic field developed by Dr. Leclerc that is large enough that you could put your leg in it unless you work out a lot with his knee brace. And so we, in our recent work, we've shown how we can scale that up, exactly what the power requirements are, but it's going to depend on the medical intervention you want to do.
And I have a follow-up question for Thomas, similar to Dr. McDonald. So, with the laryngoscope, does it still require, can it be done blind, or does it still require visualization of the chords before you get in there?
It still requires visualization. Say for a conventional laryngoscope, so without video, it would still require visualization to a certain extent.
Okay.
The visualization is much easier because the endotracheal tube is held on the inside, so you're not coming at it from a different angle. With video, it is much easier because you can always see the tip of the endotracheal tube in the corner of the video. So it's, you always have the view of the tip, and as it's going into the trachea, it's always guided. So.
Okay. All right. Thank you.
Thomas, I wanted to know how many intubations a year roughly are done throughout America, throughout the world. So
Yeah.
Tell us about your market.
So every year there's about 50 million intratracheal intubations around the world. About a third of those are in the US, and it's also the third most common procedure in US hospitals during stays. So it's very sizable market.
Question for Irene. So Irene, you described a significant set of applications of your technology, lots of algorithm development required. The clinical application bar is pretty high. Can you tell me where you are in that process?
Absolutely. We have a fantastic team. We're partnered with Dnipropetrovsk Polytechnical University in Dnipro, Ukraine. Our chief technology officer is actually a professor. And we have a team of over 20 people. Half of those are data scientists, physicists, biomedical engineers. As far as where we are, we're currently a 3-month-old company. So we don't have everything done. However, I will tell you that in 3 months, we've already filed our first copyright for an algorithm. Our core body temperature monitor is 0.2 degrees more accurate than the most expensive thermal thermometer.
Okay, for Trevor. All right. So I don't know if I missed this, but is there a certain spectrum of light that your system needs to produce?
So our catalyst is actually tunable, and so we can tune it to work with anything from deep UV to IR. And whatever light you want to emit, we can tune it to work with. Including raw sunlight. So if you want to drive chemistry with raw sunlight in space, that's a possibility.
Let's see, I think it was Jeff Yes. Why humanoid?
So you need a humanoid when you're dealing with human spaces. So they have a really small footprint, and they're best for using human tools and operating within human environments, and they're also incredibly versatile. So some people say, what is a humanoid for? What is a human for, right? They're very versatile, and they'll really help out amongst our settlements in conjunction with other robotic systems as well.
Okay, oh wait. Megan. Okay, so I'm a robotics person. I don't know a lot about sweat. So the fabric itself prevents any bacteria buildup, is what you're saying?
Correct.
Okay, so you can sweat all day and
The
no
bacteria,
it'll
the
just like
bacteria-
fall off or something.
You got it.
Okay.
Literally, the fabric inhibits the growth of the bacteria,
Okay.
so the bacteria never gets in the fabric.
I have to follow up with Megan. So I work out in Houston outside in the morning. It's the most humid part of the day. I am extremely skeptical. How extreme have you tested your fabric?
Yes, so we actually have partnered with MicroStar, which is the lab that the government uses, and put it through extremely extreme testing based on, and there's always the testing of my husband and I that just sweat like animals. But we've been testing the fabric for about a year now, both in real life as well as labs.
Quick question for Megan then. So do you have, is there an upper limit for use? In other words, or do you use it till it falls apart, or is it, you recommend someone can work out in it for a month or that sort of thing? Or?
That's a great question. As far as washing or not washing, we've tested it up to 150 washes and without any bacteria getting into the fabric or smelling. So not only is it an anti-smell, it's the antibacteria in terms of rashes, et cetera.
So for on orbit, say, where they had no washing machine?
Correct.
Okay.
Yeah, so basically, I've not tested it, I guess, where there's no washing machine, but I can say between 100 and 150 washes, bacteria will not get into the fabric, so they're at least safe for that long.
Yeah, following up on that, as far as cleaning the material, so if they go to Mars, they don't want to have a lot of changes of clothes. It's very expensive. So, is there anything you're doing that could make it easier to clean it, whether using microwaves or some kind of radiation, so you don't have to use a lot of water or chemicals or power to clean the material?
Sure. So the great thing about the material is you don't have to clean it because it is essentially is clean. The water from the sweat is getting into your fabric, but the bacteria isn't. However, I have not developed anything to clean it after that 150. I'm like, I already presented, but thank you.
I'm gonna wait till she calls on me.
Testing. Okay, so if I could have our judges exit. Chris, do you remember where the conference room is? If not, Jen? Okay. Or Joseph knows where it's at. Oh, I couldn't find you earlier.
Thank you. Thank you, guys.
And so if I can have you guys take some seats there. So do you ever feel like you're not the smartest person in the room? Every time I do a NASA iTech, I realize how little I really know about technology. And I'm an avid reader and I love technology, but I realize how little I do know when I meet you guys. So thank you for being here. What I want to do is introduce our speaker. While I'm going to step off stage in just a moment, we're honored to have join us today the Honorable Dr. Brian Babin, U.S. House of Representative of Texas 36th District, which was where I came from before I moved to D.C. to help NASA, and Chairman of the House Space Subcommittee. He's been an advocate for space and is passionate about the technologies that it'll take for us as an agency to fulfill our missions. So if you guys can please help me bring Dr. Babin up by giving him a round of applause for being here today.
I'm gonna leave that right there.
If I could just shake your hand and thank you. Thank you
You bet,
for being
Kira.
here.
Thank you.
This has been awesome. So
Absolutely.
it's all yours.
It's fantastic. Absolutely. Just looking at some of your developments and some of your experiments, I'm an avid hunter. That seemed like there'd be a great application there. And being a dentist, we always try to get to the root of problems, and I've been listening to some of the ins and outs of your developments. Very, very fascinating. Honored to be here. Very honored to be here. And I see they're bringing up my thank you. Okay, good. Yes. Well, I want to say thank you. Good evening. I'm so very pleased to have the opportunity to welcome you to Houston, Texas, Space City. And for our live stream viewers, thank you. Thank you very much for linking up with us tonight. Let's give them a hand, okay? Absolutely. Just 10 years ago, live streaming was being conquered. And now here we are, no delay in transmission and completely wireless. Technology advances are constant, and the capabilities exponentially better with each generation of development. And that's why we're here tonight, to see how NASA is changing the way government can acquire leading-edge technologies to meet their needs more efficiently and cost-effectively. And not that I'm biased, but I can't think of a better place to host a NASA ITEC event than right here in Houston, Texas. Houston is at the heart of our nation's economic engine with energy, healthcare, transportation, and agriculture, manufacturing, and of course, last but not least, space. I'm honored to represent Texas's 36th district, which includes the home of human spaceflight, Johnson Space Center, where the workforce is second to none. And I tell you what, after the visit from Vice President Pence just last Thursday, and quite frankly, since the administration has made space a national priority once again, everyone has a renewed sense of commitment and are totally re-energized. And I hope you had an opportunity to listen to the Vice President's speech. If you didn't, I urge you to do so. I want to echo the Vice President's sentiment that, quote, all the men and women who work in this great industry are national assets. And though we've achieved many historical challenges, even greater accomplishments lie ahead for America's space program. It's a fantastic time to be a part of this amazing industry. And I want to thank the NASA iTech team for their very hard work and dedication through the past couple of years. It is absolutely fantastic the way that you have taken this program across our great country and tapped into innovation at so many different levels. This is an incredible program. NASA iTech brings together people and ideas, millennials, baby boomers, individuals and teams working out of their garages, out of their offices, university labs, even high school classrooms, fostering partnerships to meet the technological needs across every business sector. However, its major thrust is identifying technologies that apply to NASA and the agency's goals. And what's unique about the NASA iTech program is that it operates in profoundly different, less traditional ways. And since the early days of spaceflight and throughout the past 5 decades, there have been thousands of technologies and billions of dollars injected into the global economy derived from NASA and our space industry. Various economists have estimated that the return on investment for every dollar put into NASA budget is as high as 14 to 1 and as low as 7 to 1. Either way, great returns. How many other government agencies provide any kind of return whatsoever? From a taxpayer and economic perspective, NASA is undoubtedly a great investment. And as a federal legislator, that's the kind of program that I will happily support any time, any day. NASA has made many extraordinary accomplishments, landing Americans on the moon, development of a one-of-a-kind reusable space shuttle system, leading the design, assembly, and operations of the International Space Station, and providing 24/7 support to the astronauts on board for nearly 18 years. Building telescopes to help us to understand more about the origin and makeup of our universe. Development of robotic rovers, orbiters, and probes to investigate every planet in our solar system, the sun, asteroids, and the moons of planets. And while remaining on the cutting edge of aeronautics R&D with faster, quieter, cleaner, and more fuel-efficient aircraft. And what I've mentioned doesn't even scratch the surface of everything enabled by NASA's incredible research and technology development. If you ask anyone unaffiliated with the space program what they believe NASA's budget would be, you might hear them compare it to the Department of Defense. Nothing can be further from the truth. It's not even close. But in many cases, that's the general perception across the country. In reality, NASA receives a minuscule amount of the federal budget, just a little over 0.5%. And yet look at all they accomplish. The Department of Defense takes up 15% of our budget. Nonetheless, as chairman of the House Subcommittee on Space, I lead the committee responsible for oversight of our nation's space program. And we have to ensure that the tax dollars that NASA receives are prudently focused and utilized, and every single dollar matters. And that's why I'm so impressed and intrigued with the NASA ITEC program and their innovative approach to finding solutions to some agency-wide challenges. Traditionally, NASA invests a significant percentage of its annual budget into technology development and scientific research, just to meet its unique requirements. Even though many of these technologies result in spin-offs benefiting other industries, NASA still has to make the upfront investment for this technological one-way street. However, with this program, the approach is changing. NASA ITEC has basically reversed this process. They send out a technology call for applications to address specific NASA needs. They conduct a Shark Tank-style competition with subject matter experts judging which technology they believe has the highest applicability, and they select a winner. And that's it. No upfront investment. In fact, at this point, there's no government investment for development at all. And the NASA ITEC program provides an invaluable conduit for networking among entrepreneurial, venture capital, industry, and government communities. But most importantly, NASA can save a substantial amount of their annual budget spent on research and development, technology development. And this is exactly the type of approach that NASA, as well as other government agencies, should embrace. Stronger collaboration and more equitable partnerships between the commercial and government sectors. Since their inception, NASA has partnered with the commercial industry, or contractors, as they are typically referred to, on nearly every single program. Commercial contractors built many of the aeronautical and space systems, the launch and test vehicles, crew modules, moon landers, satellites, rovers, shuttles, and telescopes, just about all of NASA's hardware. The commercial industry has also provided NASA services, including mission operations support, training, launch and landing support, research and development, program integration, space systems processing, and systems testing. But the typical way that government partners in contracts with or buys is evolving as we go along. This new approach leverages the resources that both the government and providers bring to the table, resulting in a two-way street to move more efficiently and cost-effectively toward their goals. The NASA ITEC program is demonstrating that the different way of doing business is possible, and they've established a great model for doing so. They're well ahead of the power curve compared to other agencies, because these non-traditional approaches are the direction that our administration wants to go. It shouldn't be a surprise that President Trump, who is a consummate businessman and that they want a more equitable balance of investment between the federal government and the commercial sector. Leaner programs, streamlined processes, higher efficiency, and reduced regulations without sacrificing performance and transparency will be the new norm. The vision laid out by the administration for our nation's space program will be dependent upon innovative business paradigms. And as Vice President Pence pronounced just a few days ago, in order to achieve these bold new challenges, such as developing an orbiting platform to provide a gateway for humans to return to the moon and eventually to set foot on Mars, NASA will require domestic and international partnerships with other agencies, as well as the commercial, academic, and nonprofit sectors. Otherwise, success will be unachievable and it'll be unsustainable. But let me reiterate with a strong element of caution. Success will require a balanced approach. Neither the government nor the commercial sector can go it alone. Beyond resource challenges, we still have substantial technical challenges. Safe and successful human exploration of deep space requires us to understand and mitigate some of the negative effects of long-duration spaceflight on the human body, including vision loss, bone density problems, muscle mass, and exposure to high levels of radiation. We need to continue development of better systems for water purification and growing food. We won't have cargo ships transporting supplies like we do for the International Space Station. We need a means to provide general and emergency health care, as well as ongoing hygiene, which is all pertinent and relevant to the very things that you folks have shown us tonight that we've enjoyed. In other areas, advances in robotics have impacted every industry globally and is currently one of the fastest growing fields. Industrial and non-industrial market revenue for the global robotics industry is projected to be nearly $500 billion by 2025. NASA uses robotic systems extensively already. However, the philosophical debate about whether we should send humans or robots to explore space will likely continue unanswered. Is it safer and more cost-effective to send robots? Well, sure it is. But humankind is meant to explore and to discover. It's an innate desire which robots do not possess, at least not yet. Astrophysicist Neil deGrasse Tyson has often stated, "What kid ever said, when I grow up, I want to be a robot?" They don't. They want to become an astronaut. And it's very simply stated, and he's right. The focus of this particular NASA ITEC event is autonomous robotics and medical research. And I'm going to show my bias again, even pick on California a little bit. But both of these topics are undeniably areas of expertise for not only Houston, but for JSC in particular. The capabilities of this region and this center may not be as visible, but you don't need to go all the way to Silicon Valley, and Houston has a much lower cost of living, I can assure you. There is no doubt that NASA and the broader space industry continue to provide tremendous contributions to the American and global economies. That directly ties to what you are doing this very evening, demonstrating entrepreneurial spirit and ingenuity through your technology, and while potentially helping to address some of NASA's challenges. Technology development and strong partnerships are undoubtedly a critical enabler to our nation's space leadership and economic competitiveness. I want to commend all of the teams who presented this evening. The work that you are doing is as incredible as it is fascinating. And I wish you the very best in this challenge. And though there is only one winner emerging from tonight's NASA Shark Tank, do not be discouraged. The fact that you are here means that your idea caught the eye of NASA's attention. And I want to say how much I have enjoyed being here. I look forward to hearing the outcome of our judges, and I want you to have a great evening, and God bless you. Thank you very, very much. Appreciate it. Thank you.
So good evening. Do I need to play some shark music? A drum roll. Could I get your attention, please? Thank you. It's always difficult sometimes to get your attention. Well, I will say that my team and I we actually met our goal, which is to make it very, very difficult for the judges when they go in and convene. I always feel sort of gratified, like, yes, we did our job. And so this time is no different. What I will say is the winner of tonight's event, which is right here. I don't have a fancy envelope, sorry. I work for the government, and you should be glad that I don't waste dollars on that. But I will say that this is always the most difficult part for me, because as companies presenting your technologies, they're all amazing. You guys are doing a great job, and it's not easy to be an entrepreneur. It's not easy to commercialize a technology, but you guys are amazing, and so I hope you still apply for this forum. It's 5-page white paper. It's open through the 31st and till midnight West Coast time. We learned that lesson too early. But anyway, so I'd like to announce who the winner is. What you'll win is you automatically earn a spot as the top 25. I've explained it to you before, but I'm going to explain it to the audience. When we receive all the proposals in, we have a nonprofit organization that vets those technologies. And then they deliver to NASA the top scoring 25 proposals. And out of those top scoring 25 proposals, NASA evaluates, our chief technologists evaluate those proposals for their space application. In order to make it into the top 25, they evaluate it for their commercial market viability of the technology and space application. And so it's pretty significant, because it means that when you make it into the top 25 automatically, you sort of skip that process. If we have 100 proposals that come in, then you're automatically one of the 25. If we have 100 proposals that come in and our chief technologists only see the top scoring 25, and even that is really challenging. Our team or our chief technologists can they can attest to that. It's difficult. So the winner for tonight, and it was tough. I just have to say, it was really, could we get some shark music or something? It's the Danish Aerospace Company. There you go.
Thank you very much.
So, Dr. Babin, could I get you to come up, and we're going to take some pictures. You guys all stay on stage. And if you could come here, sure. We're going to get some pictures. Thank you. I just had to hide it because people peek when I come on stage, and I'm not, I can't hide the whole picture frame. So if we can just get a picture like this with everyone and the winners. I don't know where my camera is. Their camera person? Oh, Harla, she's over there. Thank you, Harla. Can we give one more round of applause for everyone, judges and participants? Thank you, everybody, for joining us this evening. Please mingle, walk around the tables, meet with the entrepreneurs. You guys get to your tables so you can show them your cool devices. Thank you, everyone, for participating.